In this presentation, we'll be looking at the organization and graphic presentation of the data. So when we do surveys or any research, we gather a lot of information or the data. So once I have the data, how can I make sense of it? You can also think about what I found through my research. What can I communicate to other social or health scientists or policymakers? How can I communicate my findings so that readers will understand it, and how I can summarize it? So the pictures that we can show picturize our data. It has a lot of importance, and it has the capacity of thousands of words. But we need to be very cautious of misrepresentation of data. The two formats are frequently used for summarizing data. One is frequency distribution, and another is the graphs. Both the formats are useful in visualizing the distribution of the measurement of variables within the data set compiled from a research sample or population. Both formats also suggest certain visual trends in data sets, such as possible relationship between two variables. These formats provides clear and dramatic evidence for the researcher's argument. In this particular presentation, we'll be looking at frequency distributions. So we want to know how many persons are part of each value category for the variable that we measure, how the research sample is vary from one to another. So we need to visualize spreading of value categories or value variables. We construct frequency distribution tables. So the frequency distribution is a table reporting the number of observations falling into each category of variables. The proportion and percentages. Here the relative frequency obtained by dividing frequency in each category by total number of cases. So to find proportion, we need to divide the frequency in each category by the total number of cases. And now you can do it by your calculation by calculator or by on your paper. You can also use SPSS to do these frequencies. The frequency distribution is a relative frequency obtained by dividing the unique frequency in each category by total number of cases and multiply it by 100. So that's how you calculate percentage. Here in this example, table 2.2, you can see the frequency and percentage distribution for categories of region of birth for foreign born in 2012. So for Mexico, 28% people they're born in Mexico, and in the column frequency you can see the actual number of people born in these particular regions, and then the third column talks about the actual percent, and this percent is from the out of this 40,000 40 million 738,224. Out of this total number, what particular percent for each country of birth? So these are listed here, and total percent is 100. Then the frequency distribution is also as you were discussing about the different types of variables in the previous chapter on it is like categorical variables or numerical variables. In categorical variables we have nominal and also ordinal variables. So how those variables can be applied in terms of our practice. So here you can see the example of male and female. So in the second column you can see the tallies for male, like 5 5 5. So total 15 number of male, 5 5 5 5. So 5 times 5, 25 frequency for female. And then out of 50, what percent of male. So 15 divided by 40 into 100 is 37.5, and similarly 62.5% of female. So these are basic tables of frequency. This is another example of ordinal variables. Here we can see the frequency distribution of variable degree. This is from GSS sample, less than high school, bachelor, graduate. So how many number of frequency in those degrees, and what percent of those degrees. So these are listed in these frequency tables. This is another example of frequency distribution here, that is called cumulative frequency distribution. So here what we do is the distribution shows the frequency at or below each category of the variable. So in this example, grouped frequency distribution and cumulative for variable age. So this age group is like numerical variable, and you can see different intervals here for each age category. So you have frequencies, how many people for each categories are there in our sample. And then in the third column, so we have 7 frequency for age 20 to 29. Then for age 30 to 39, we have 7 frequency. So in cumulative frequency, what we do is keep adding on the frequencies below. So we have 7 here, cumulative frequency for first age category. Then we add this 7, so it becomes 14. We add 12, then it becomes 26. So in 26 we add 3, it becomes 29. So for each category we keep on adding the frequency, and the total for both should be the same. And then this is another example of frequency. So here it is cumulative percent distribution. What we see here is in previous table we saw the cumulative frequency. Here we are focusing on cumulative percent. So we have first column with age category, second column frequency for each category, how many people were there, and in third column we have percent, and the fourth column cumulative percent. So this third column is percent of how, like out of 40 number of people, how many of them were 7, how many of them were in this first category. So it is 17.5%. So similarly for each age category we have list of percentage here, and total is always 100 because we are looking at the percentage always accounted in 100. So for cumulative percent, what we do here, we take first cumulative for first age category, then we add the second age category percent, that is 17.5. So 17.5 and 17.5 is 35. So in 35 we add 30, it becomes 65. In 65 we add 7.5, it becomes 72.5. So similarly it keeps on adding, and then at the end it becomes 100. The next is bivariate variables. The name itself shows bi means two variables. What do we do with two variables? We create a table that displays the distribution of one variable across the categories of another variables. So we have columns and rows. Column typically represents the variables. Those categories are in columns. Usually they are independent variables, and the rows represent the categories that those are typically the dependent variables. In this example you can see this is like cross tabulation or bivariate variables, home ownership and by race. So here the race is like vertical column, and it can be, we can say it is like independent variable. So the race may determine the type of ownership. Is it owned house or rented house? So in the rows you can see the home ownership, and the vertical columns are races. So this is how it looks like. So for blacks who owns the house are 33%, whereas whites who owns the house are 64%. Similarly, for rent, uh, the blacks who owns the blacks whose home ownership is rental, they have around 67%. However, the whites who have a rented properties, they are 36%. So likewise, this is like a bivariate table, another way of representing our data. So in this presentation, what we have seen is types of uh, different frequency tabulations, be it frequency cumulative or frequency percent cumulative or bivariate variables. So we have seen different examples of representing our data that we have created through frequency tables. Thank you so much, and we'll look into the another part of the presentation focusing on the graphs.